Hi everyone, in this series of tutorial presented to you by Robotics Technology Private Limited, we'll see about ACs and DCs. AC is alternating current, DC is direct current. We'll see how it differs and what way we could use it and how it is useful for robotics, why the knowledge of ACs and DCs are important for robotics. If you could see, for example, almost all electronic devices runs on DC current. Electronic devices runs on DC current. Alternating current is something which you get in households. I'll say about alternating current and direct current few examples with few similarities and all. So first is battery we have, and I'm going to run a motor using it like this. Now it's very well known that electrons force from plus to the motor and it ends to the minus negative of the battery. This is in the condition of DC. If I'm going to have an AC supply like this, we have normally a 3-pin socket, and I'm going to connect it to the lamp like this, and now the lamp glows, as we all know. In the first phase, the electrons from this part will flow to the lamp and it glows, and it goes and closes the circuit. First phase. Second phase, what happens is this, from this point it comes in the reverse direction of the previous phase. It goes like this and it comes back to this place. This is the form of AC. Flow of electrons in first phase will totally differ in the second phase. This could be easily understood using a graph. This is a graph for DC current. Its voltage is quite simple and same. For AC, it has a sinusoidal waveform. This is for one-way electron flow and this is for the other way electron flow. This is how it differs. And why do we have a AC socket and not a DC socket? ACs are safety for human beings, safety for humans, safety for devices. What way it is safety for human beings? For example, just I'm going to give an example. Don't try this in home, just for the sake of understanding. We all have received shocks in our day-to-day lives. For example, if I'm going to insert my finger into these sockets like this and I'm going to switch on, what will happen? We will receive shocks, right? So these shocks, for example, I'm going to receive a shock. Household supplies are mostly 230 volt, particularly in some Asian countries. Household supplies 230 volt. I am going to receive a shock up to 230 volt and it goes to 0 again, because it's the second phase and it goes back from 0 to 230 again. In this part of current flow, this part of voltage actually will have chance for me to take my fingers out from the socket. Whereas if I'm going to get a DC shock, I'm going to get a total shock until I'm going to lose my balance or else I die. So this is how it is safety for human beings. And safety for devices, we can't expect every time to just see which is plus and which is minus and to plug in, because AC has no polarity. AC has no plus and minus. For example, you could plug the socket plugs into either way, right? So how could you do that? Because it has no plus and minus, and we can't expect ourselves every time to plug plus to plus, minus to minus. During times at the time of bed, we actually plug in chargers. At the time of sleeping itself, we know where the socket is and we do plug it actually. At that time, we can't expect to plug plus and minus minus. So this is the time, and this is the reason we have a AC over here. And we have one more thing actually, transmission losses are very less in ACs. Transmission losses, because power generated is somewhere about some 100 to 200 kilometers away from our residence, and that has to travel from that place to over here. So that has considerable amount of losses. So that loss is very less in AC compared with DC.